Video lecture we are going to see pumps. Myself am Rajakumar, assistant professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Pumps nothing but a hydraulic machine which convert mechanical energy of prime movers into pressure energy. The prime mover is nothing but a motor or IC engine. Pumps have wide application in pumping of water, fuels, chemical, viscous fluid like lubricants. Water pumps are used to pump water from bore wells or open well for residential buildings and agriculture purpose. Also used for cooling of petrol engine, diesel engine, gas turbine, exhaust steam in condenser in power plants. Fuel pumps and lubricating oil pumps are used for the operation of IC engine, gas turbine, steam power plant, etc. In automobile industry, pumps are used for automobile transmission, power steering, hydraulic brake, etc. In the field of agriculture, pumps are used for hydraulic driven farm equipments. In the field of material handling, pumps are used in the earth moving equipments, cranes, lift, etc. In municipalities and corporations, special pumps are used for sewage disposal. Then the types of pumps and their applications: reciprocating pumps, centrifugal pumps, compressor pump, and submerged pump. These are the pumps are used to pump water to overhead tank in buildings and also for agriculture purpose. Then van pumps, gear pumps, injector pump, and different types of fuel pump, screw pumps. These are used to pump the in which the these are the pumps are there in which the vane pumps are used to pump the semi viscous flow. Gear pumps used for pump the viscous oil for lubrication. The injector pump are used to pump the boiler feed water during this operation, and different types of fuel pumps are used for to pump the petrol or diesel oil in IC engine, and screw pump used to pump liquid mixed with solid materials. Next classification of pumps. Broadly, pumps are classified as reciprocating pump, centrifugal pump, compressor pump, submerged pump. The reciprocating pumps are classified as single acting and double acting. First, we are going to see the reciprocating pump. The reciprocating pump is a device that converts mechanical energy into hydraulic energy by sucking the liquid into a cylinder. In this pump, a piston reciprocate which uses thrust on the liquid and increase its hydraulic energy. A reciprocating pump is also known as called as positive displacement pump because it discharges a definite quantity of liquid. It is often used where a small quantity of liquid is to be handled and where the delivery pressure is quite significant. It consists of, you can see this figure, this is the single acting reciprocating pump. It consists of cylinder, suction pipe, delivery pipe, suction valve, delivery valve, piston rod, crank and crank connecting rod. These are the important parts in which the cylinder, a cylinder means the in which the piston is moving to and fro. The movement of the piston obtained by a connecting rod which connecting the piston and crank. Then suction pipe. What's the purpose of suction pipe in the reciprocating pump? It is the source of water that connecting the cylinder together. The suction pipe allows the water to flow in the cylinder. Then delivery pipe. After this process, the source of water leaves the cylinder and discharges through the delivery pipe. The delivery pipe joins the pump cylinder to the discharge outlet. Then suction valve. The suction valve is used to flow of water enter from the suction pipe into cylinder. It allows only one direction flow, hence it is also known as non-return valve. This valve is found on the suction pipe inlet. Then delivery pipe. With this valve, the flow of water is discharged from the cylinder into delivery pipe. It is also non-return valve located between the delivery pipe outlets. This valve is in the closed position during suction. Then piston and piston rod. It is a solid part that act back and forth inside of the cylinder for the suction and delivery for the liquid, whereas the piston rod helps the piston to move in a linear direction. Then crank and connecting rod, strainer, air vessel. These are the parts. Then the single acting. Next, we are going to see the Working principle of single acting reciprocating pump. In this pump, a cylinder in which a piston moves forward and backward. The piston is reciprocating by means of the connecting rod. The connecting rod connects the piston and the rotating crank. The crank is rotating by means of electric motor. The suction and delivery pipes with the suction and delivery valves are arranged in the cylinder. The suction valve allows the water into the cylinder and delivery valve leaves the water from the cylinder. As the crank rotates during the first stroke of the piston, that is the suction stroke, that water enter into the cylinder in a suction stroke. The crank is rotate from A to C, that is a 0 to 180. The piston is moving towards the right side of the cylinder. During this, the vacuum created in the cylinder. The vacuum causes the suction valves to open and the water enter into the cylinder. In the next stroke, that is called delivery stroke, the water leaves the cylinder. In the delivery stroke, the crank is rotate from C to A, that is from 180 to 360 degree. The piston is moving to the left side of the cylinder. Due to this, the pressure of the liquid increase inside the cylinder. This pressure causes the suction valve to close and delivery valve to open. Then the water is forced into the delivery pipe and rises into the record height. Next, we are going to see the working principle of double acting reciprocating pump. In this, the water is acting on both sides of the piston. You can see this figure. There's the two suction pipes and two delivery pipes are required. And two delivery pipes are required for double acting pumps. When there is a suction stroke on one side of the piston, at the same time there is a delivery stroke on the other side of the piston. Hence, for one complete revolution of the crank, there is two delivery stroke and the water is delivered. Then working principle of double acting reciprocating pump. When the crank connected to the power source, that is motor, it will start rotating and the connecting rod and the crank will also be in the movement as the piston moves to its right, creating a vacuum inside the cylinder. This causes the suction valve to open. Now the liquid from the source is sucked into the cylinder by the suction pipe. Similarly, when the crank moves inwards of the cylinder, the piston will move to its left, compressing the liquid in the cylinder. At this point, the pressure is generated, causing the delivery valve to open and the liquid flows through the delivery pipe. Finally, the piston reaches its extreme left position and all the liquid in the cylinder is delivered through the delivery valve. Again, the crank spins outwards and the piston moves to the right to create the suction and process is repeated. Then single acting pump versus double acting pump. In single acting pump, one suction pipe only. In double acting pump, two suction pipe. In single acting pump, one delivery pipe only. Here, two delivery pipe. Water act on one side of the piston and water act on both sides of the piston. Then discharge of reciprocating pumps. For single acting, discharge of the pump per second Q equal to LAN divided by 60. For double acting pump, discharge of the pump per second Q equal to 2LAN divided by 60. Here, where L equal to length of the stroke of the piston in meter, A equal to cross section area of the piston meter square, and N number of revolution per minute of the crank. Then slip of the pump. It can be defined as the difference between the theoretical discharge and actual discharge. Next, we are going to see centrifugal pump, in which the mechanical energy of motor is converted into pressure energy by means of centrifugal force acting on the fluid. It consists of impeller. Impeller means a wheel with series of backward curved ones casing airtight chamber surrounded the impeller. Then suction pipe. One end is connected to in I and the other is dipped in a liquid. Then delivery pipe. One end is connected to I, other to over tank. Then foot valve. Then allow water only in upward direction. Strainer. Prevent the entry of foreign particle or material to the pump. Next, we are going to see the working principle of centrifugal pump. When a certain mass of fluid is rotated by an external source, it is thrown away from the central axis of rotation and centrifugal head is immersed, which enable it to rise to a high level. The delivery valve is closed and the pump is primed, that is suction pipe, casing and portion of delivery pipe up to delivery valve are completely filled with the water so that no air pocket is left. Keeping the delivery valve is closed, the impeller is rotated by motor. Strong suction is created at the eye. Speed enough is to pump a liquid. When it is attained, delivery valve is open. Liquid enter the impeller van from the eye, come out to casing. The impeller action developed pressure energy as well as velocity energy. Water is lifted through delivery pipe up to record height. When pump is stopped, delivery valve should be closed to prevent back flow from reservoir. Then the difference between the reciprocating pump and centrifugal pump. Reciprocating pump means can be used for higher head purpose. This is centrifugal pump used for medium head purpose. Reciprocating pump can pump less quantity only. The centrifugal pump can pump large quantity can be pumped. Then reciprocating pump discharge is not continuously, but centrifugal pump continuously flow. The centrifugal pump cost is high and reciprocating pump is cost is high and centrifugal cost is low. Cannot be high speed in the reciprocating engine, but centrifugal can run in high speed, and reciprocating pump cannot pump viscous fluid. Then centrifugal pump can pump viscous fluid. Cavitation is the formation of bubbles or cavity in liquid developed in area of relative low pressure around an impeller. The collapsing of these bubbles trigger intensive shock waves inside the pump, causing the significant damage to the impeller and or the pump housing. Thank you.